The hypothesis that we originally stated that the mass of the penny increases with age or decreases with age is not entirely true. Albeit older pennies are heavier than newer pennies, it's not a gradual change. In fact, it seems like there's a drop right around here, okay, that it goes from about 3 grams to about 2.5 grams. So our original hypothesis, which actually happens a lot in science, leads us to a discovery that is more important to pursue. So that's what you get a lot in science. You have these eureka moments, serendipity moments, where you're doing a research, you're doing a study, and then the results are unexpected. And this is an unexpected result for anyone who thought that the mass of a penny would gradually increase with age or decrease with age. Because if it were a gradual change, you would see trend lines that would eventually mean that it was going up rather than this drop. So when you go back to your hypothesis, you can certainly say in your conclusion that my hypothesis might be that older pennies are heavy, but it's inconsistent that it gradually increases, okay? Something unexpected occurs. And like I said, this happens a lot in science. I don't know if I told you guys a story about Alexander Fleming and how he discovered penicillin. It was a serendipity moment. Alexander Fleming, he's a British scientist, actually had a lab where he did a lot of research in bacteria, and his lab was a mess. You had petri dishes everywhere, glassware everywhere, you had broken glassware everywhere. People were ashamed to go into his lab. But it just so happened this one summer, he had a visitor come in, and he was showing him his research, and he discovered that one of his many unwashed petri dish had a bacteria colony. And this colony showed that the bacteria were inhibited from growing because it was contaminated. So he asked his colleague, well, this is what the bacteria should look like, but it seems like something's contaminated this. So he took this petri dish and put it on the side, and he continued on with the tour. But when he had time, he looked back at that petri dish, and he tried to isolate that particular chemical that was killing the bacteria. He found out that that particular contamination was from a spore, from a mold that a research group from downstairs was studying. It just so happens that it got airborne, it got into the vents, and it hit one of his petri dish. And he discovered that the active ingredient for that particular mold was penicillin. And so Alexander Fleming was actually a key contributor for penicillin, because penicillin, you know, is antibacterial medication that if you have an infection, you take it and it'll kill the infection that you have. And so through that serendipity moment, he discovered penicillin. Before penicillin was discovered, a lot of people who got injured in wars, the reason why they died wasn't because of the injury, but it was because of the infection that happened because it was contaminated. So what would happen, especially in the Civil War, was that when they got injured, they would get amputated. And that's the only way to control the infection. So you had a lot of amputees. And of course, a lot of these war veterans needed to take a lot to kill the pain, and so a lot of them were addicted to morphine. So after penicillin, they discovered that if you take it, it takes care of the infection, and you don't need to amputate the legs. So that's an example of a serendipity moment that was integrated through the scientific method. And that's not so different from what we discovered here. We found a serendipity moment in which the mass of the penny, there's something that happens to the mass of the penny right around 1980, 1982. Originally, it was about 3 grams, and then after that date, it drops to 2.5. So we have to propose another hypothesis. What happened to the penny after 1982? Now the hypothesis is that because it's a lower mass, they decrease the size of the penny. So all we have to do is check the volume of the penny and see that it's smaller, and that would account for the smaller mass. Or maybe there's another hypothesis that they changed the material of the penny altogether. Older penny is made out of a different penny, different material than newer pennies. Maybe older pennies were pure copper, and newer pennies are copper coated and cheap metals in the inside. If you recall, maybe you guys weren't born in the 1980s. A lot of you were probably were not around. But 1980, Reagan was the president. The country was undergoing a depression. 1982, I just graduated from college from San Diego State. Couldn't find a job because the economy was bad. It was actually a fortunate thing because I went on to graduate school, but people were hurting for money. So maybe they decided that year that they needed to do something with the penny in order to make the penny cheaper. These days, we have a similar revolution. It's actually costing more money to mint a penny than it's worth. You know, it costs about $1 something to mint a penny, and it's only worth 1 cent. And so a lot of people are hoarding pennies and extracting the copper or something, because coppers are pretty expensive. So the government's toying with the ideas that maybe we don't need pennies, okay? But nevertheless, what you guys should do is write a hypothesis as far as why the penny dropped after 1982, and then we're going to do an experiment. You guys right now have stacks that are pre-82 and post-82. Combine with another group and exchange stacks. Maybe one group will have all post-82, maybe another group will have pre-82. Combine with another group so that you have 25 pre-82 and 25 post-82. Wait there. What you guys will do is, one group will take the post-82, okay, and you guys are going to take all 25, take your balance, okay, tear it, and then weigh the post-82 pennies all together, all 25 of them. And then you're going to write this down. By the way, part 2 is found on page 204. Go to your lab manual. Go to page 204. If you don't have a lab manual, you can write this on a piece of paper. Okay? Because part 2 is found here. And the reason why I put it there was so that you guys won't jump ahead. Okay? But on page 204 is where part 2 begins. What you guys are going to be doing is you're going to take 25 pre-82 or post-82 pennies. Only work with one. Weigh them together. Okay? And so you can see on the table on page 205, the mass of 25 pennies. That's what you want to do. And then find your other group, the other partner that does the pre-82, and get their data. You guys are going to be exchanging data. And then what you guys are going to be doing next is you're going to take your graduated cylinder. This is a 50 ml graduated cylinder. You're going to fill it up with about 20 milliliters of water. Okay? 20 milliliters of water. Fill it up to about the 18 milliliter mark, and then use a pipette to make sure that it's exactly at 20 milliliters. So you want the bottom of the meniscus to be exactly at 20 milliliters. Okay? So that's what I'm doing right now. Okay, it's exactly at 20, so I would write the initial volume as 20.0. Okay? I would take my 25 pre-82 pennies, and I have to be very careful with this because I don't want it to splash, because if it splashes, it's going to cause error. What I want to do is I just want to take my 25 pennies. I know my initial volume. I'm going to slide my 25 pennies in the graduated cylinder so that all 25 pennies are submerged below the water line of the water. And then when all 25 pennies are there, I'm going to read the final volume. The difference between the initial and the final is the volume of the 25 pennies. That's what you're going to write down on page 205. So we're determining the mass of the 25 pennies, we're determining the volume of the 25 pennies. The density is a good way. The density of a material is characteristic for that material. Copper, pure copper, has a certain density that you could easily look up. If it's pure copper, you are going to discover that the density that you measure, the mass of the 25 pennies divided by the volume of the 25 pennies is equal to the density of 1 penny. Okay? For the pre-82, you would do this calculation. For the post-82, you would do this calculation. The calculation is found on the next page. You can see that on page 206. But what you guys are going to be doing is you're going to be obtaining the density of the pre-82 versus the post-82. Now, if the material are indeed different from each other, you're going to get a different density. Okay? And so one is going to have a higher density than the other, or one's going to be lower than the other. If the material are identical, the density will be the same. That means maybe the size of the penny has changed. So this is one way to determine whether the composition of the pennies has changed after 1982. Okay? Determine the density. And then the next step is to actually take a penny and cut it up. And look, do a visual inspection that the pennies before 1982 are different from the pennies after 1982. And if you look real closely, I can tell you that they have different colors. And so that is a sure signal, evidence, scientific evidence that these things are different material. So these things together will support maybe that the composition was changed. Finally, the last thing you want to do is take each one of these pennies, and they will be found under that hood, each of these penny have, and reacted with acid. Copper does not react with acid, but cheap metals like zinc or nickel will. And so if you find out that one of these halves will react with acid, show bubbles, and the other does not, then again it's evidence that the composition of the penny has changed. Remember, you guys are gathering evidence to support your hypothesis, but if your hypothesis is incorrect, then you have to go back and alter your hypothesis so that it's consistent with the experiment. And that's what the scientific method is about. You have an observation, you have a question, you propose an explanation, you propose a hypothesis, you conduct experiment to verify that your hypothesis is correct, but if it's not, then you have to alter it. And so at the end of this lab, what you guys are going to do is discover through the experiment whether or not the pennies are different in terms of the size or different in terms of the composition. You're going to cite the evidence, and then you're going to, on the bottom of page 206, you're going to show a flow diagram, and the flow diagram is nothing more than the scientific method diagram where you have an observation, a hypothesis, an experiment, and you're being more specific. The observation, what happens to the mass of the penny with age? The hypothesis, it increases because it picks up dry. Experiment, I measure the mass and plot it against the graph. Go back, have to revise the hypothesis, not entirely true. Do an experiment, measure the density. So that's the type of block diagram that you want to do for page number 3. As soon as you answer that questions and you do the calculations for the density, you guys are done with this lab.